Hello friends, welcome to the new video lecture of data structure subject. In this video lecture we are going to learn about queue. Okay, so previously we have studied about stack and now we are going to learn about queue. So queue is a ordered collection of homogeneous element. It is a non-primitive linear data structure. When a new element is added at one end called rear and the existing element are deleted from the other end that called front end. Okay, so here we will delete our element at the front and we will add our new element at the rear. This mechanism will called first in first out, means which person or which element is first come, then that will go first out. Okay, so here our total number of elements in queue will be rear minus front plus 1. That we will understand deeply by different examples. So consider this figure. Here we have an array of size 5. This is the front of queue and this is the back, or we can say rear of queue. If we want to delete some item, then it will apply on this front part, and if we want to add some item, then it will apply on this rear part. Okay, another example. Here we have write Enqueue and Dequeue. In queue we will know insertion as Enqueue operation and deletion as Dequeue operation. So Dequeue will perform on the front end and Enqueue will perform on the rear end. Okay, so insertion in element queue known as Enqueue and deletion is known as Dequeue. Okay, so placing an element in a queue is called insertion or Enqueue, and it will be performed on rear. Okay, so this is the queue. 1, 2, 3 and 4 person are available in this queue. So this is the front of queue, means first person. And if we want to add or if we want to enqueue some item, that it will be added on the rear of our queue. So this is enqueue operation. Second, removing or deletion will be performed on the front of the queue. So here you can say this is the front of our queue and this is the rear of our queue. If we want to delete, if we want to dequeue the item, then it will be performed from the front side. Okay, so enqueue algorithm is, if rear is equal to max size minus 1, then print queue overflow. Means if we want to add some item, then that item will be, so if our rear is the max size minus 1, means at the last index, so our array is full, so we cannot add any items in it, so we have to print there queue is overflow. Okay, so we cannot perform our enqueue operation. And if our rear is not equal to max size minus 1, means if we have space in our data structure, then we can perform our enqueue operation. So for the perform enqueue operation, or we can say for the adding element, we have to increase our rear, means rear is equal to rear plus 1. As same like stack, in stack we were increasing our top plus plus, so here rear plus plus. Okay, and after increasing our rear, we will do queue of rear is equal to item, means we will store our item into queue of rear. Okay, so this is the enqueue algorithm. Now next, dequeue algorithm. Dequeue means deletion. If front is equal to rear, then print queue is empty and return. So basically in starting, our front and our rear both will be on -1, means both will be equal, means if we do not have any value in our queue, then we cannot perform any dequeue operation. So we will print queue is empty. And if our queue is not empty, then we can perform our dequeue algorithm, or we can say we can delete item from the queue. So for it we have to perform front is equal to front plus 1, because our dequeue operation will perform on the front. So front is equal to front plus 1, and queue of front will be item, means our next item will become our next front. Okay, so this is the dequeue algorithm. Now let's see the applications of queue. Real life applications are waiting in line, waiting on hold for tech support. We all have faced this situation. We can say a movie ticket line, or we can say a line at the any account section. So this is the real life examples of queue. Okay, so now let's see difference between stack and queue. So first, stack. In stack, insertion and deletion of any element can be done by one and only. There we were using top for the insertion and deletion. And example, our push and pop operations will perform only and only on the one end, which is top. At the queue side, in queue, insertion and deletion carried out by two different ends. For example, if we want to perform our enqueue operation, then we will perform at the rear, and if we want to perform our delete operation, then we will perform at the front end. Okay, so another example, or we can say another difference is stack is LIFO, means last in first out, and queue is FIFO, means first in first out. At the stack side, stack is useful for expression conversion and evaluation, means we have seen example infix to prefix, infix to postfix, different examples of evaluation of infix and postfix operations. At the queue side, queue is useful for prioritizing job in operating system, for categorizing data, and for simulation. Okay, so another example with difference. If we have data 10, 20 and 30, then this upper side is the stack. In stack we will add this type of data 10, 20, 30. Our top will be at this point. This is the explanation, or we can say representation of queue. So 10, 20 and 30, our front will be 10 and our rear will be 30. If we want to add more item, then our rear will be increased and it will go here, and we can add item here. If we want to add item into stack, then we have to increase top. Top will be at this point, and we can add item at this point. Okay, so this is the difference between stack and queue. Now representation of queue. So different steps are there for representation of queue. First is creation of queue, second one is insertion, or we can say enqueue operation, third is deletion, or we can say dequeue operation, and fourth one is display. So first, creating queue. So for creating queue, we will have to take a structure, and at that structure we have named as queue. In it we have taken an array, we have declared a front and rear, and also take a variable queue of this queue structure. Okay, now if we want to insert element, or we can say if we want to perform enqueue operation, then here we have 10, 20 and 30 already in it. So before performing insertion or enqueue operation, we have to know that if queue is full or not. if our queue is full, then we cannot perform our enqueue operation. So queue full operation is here. It will check if queue dot rear is greater than or equal to size minus 1. Means if our queue dot rear is equal to or greater than, means here we have total 4 size array, so maximum size will be 3. So if our queue dot rear is equal to 3 or greater than 3, means our queue is full, so we cannot perform our enqueue operation. So if this condition is true, then we will return 1, means queue is full, and if this condition is false, then we will return 0, means this queue is not full. Okay, so after checking queue full operation, we will perform our queue insert operation. Okay, so in queue insert operation, if queue dot front is equal minus 1, then queue dot front plus plus means increase in front, queue dot queue plus plus rear is equal to item, means our front and rear both are on minus 1, so we have to increase both of them. We have to put both of them as 0. So queue dot rear will become 0 and also queue dot front will become 0, and at this queue dot rear we will add our item. So for the only and only front is equal minus 1, we will perform queue dot front plus plus. Otherwise we will perform only and only queue dot rear plus plus. Okay, so this is the insertion operation in queue. Now let's see dequeue operation. So in dequeue operation, we will have to check our queue is empty or not. Why? Because if our queue is empty, then we cannot perform our dequeue operation. So for it, we have to check queue dot front is equal minus 1 or queue dot front is greater than queue dot rear. This both conditions says that our queue is empty. So we will return 1, means our queue is empty. After checking that condition, we can perform our dequeue operation. So in it, we have taken an item. That item means queue dot front will be saved into this item, and we will do front plus plus, means our deletion operation, and after performing deletion operation, we will print delete the item here. Okay, so this is a dequeue operation. Now last, fourth operation, that is display operation. For display operation, we will use a simple for loop, and we will go from front to rear and print all the values here. Okay, so this is examples or operations of queue operations. Okay, so here we have seen insert, delete, queue full and queue empty operation. So this is it for today's session. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, students.